Do you know how to calculate the order of each reactant and deduce the rate expression from experimental data? If you don't, stay with me to the end of this video and I'll teach you how to crush this question every single time the IB asks for it. This is Mr. Diego Tutoring.
Let's go.
Determine the order of reaction for each reactant and the rate expression. So I'm going to teach you how to calculate it using a data table with experimental data. So the first thing that you have to know is that the rate is always equal to a constant that you're going to call K times the concentration of all the reactants, in this case, 2 reactants, to the power of their orders. Then you might ask me,
Mister, what is an order?
Good question, my child. Stay with me and I'll teach you.
the order is the effect of changing a concentration in the rate, and that is always exponential.
Mister, I still didn't understand.
Stay with me until the end of this video and I promise you will understand. So first, let's calculate the order of O2. How do we do that? We need to find a set of 2 trials or 2 experiments in which the concentration of O2 changes, but the concentration of the other reactant, in this case nitrogen monoxide, stays the same. If you look at experiments 1 and 2, the concentration of oxygen is doubling. It's going from 0.010 to 0.020, and the concentration of nitrogen monoxide is staying the same, 0.020 and 0.020. Once you have chosen your sets of experiments, use this little formula right here. What you did with the concentration to the power of the order is equal the rate effect. So what did we do to the concentration? Well, it went from 0.010 to 0.020. So we doubled it. So I'm going to put a number 2 over here to the power of the order that I called B for oxygen. What happened to the rate? What is the rate effect? It went from 0.028 to 0.057. If you divide these 2 values in order to find out what happened, is going to be 2.03. You can approximate that to a whole value as long as it's 2.0 something. So the rate effect was also approximately 2. Then you should ask yourself, 2 to the power of B is equal to 2. B being the order of oxygen. Well, 2 to the power of 1 is equal to 2. Therefore, B is equal to 1, and we can safely say that O2 is a first order reactant. Now we repeat the same steps to figure out the order of nitrogen monoxide. We need to find a set of experiments, they don't have to be in sequence to each other, in which the concentration of NO changes, but now the concentration of O2 has to stay the same. So look at the green parts. Between experiments 2 and 3, the concentration of nitrogen monoxide, or NO, went from 0.020 to 0.040. Therefore, the concentration of NO doubled. So we're going to put here that the concentration doubled to the power of the order. And what was the rate effect? Well, between experiments 2 and 3, the rate went from 0.057 to 0.227. Look over here at the top right. Divide the larger number by the smallest number. The real division is going to give you something of the likes to 3.98, which we can approximate to 4. So we doubled the concentration and the rate was multiplied by 4. The reaction got 4 times as fast. So 2 to the power of what exponent is 4? 2 to the power of 2 is 4. So if A is equal to 2, we can safely say that nitrogen monoxide is a second order reactant. Let's formalize it in the form of a rate expression. So we're going to say that the rate is equal to K times the concentration of NO. We calculated that NO, or nitrogen monoxide, is a second order reactant. So times concentration of NO to the power of 2 times the concentration of oxygen. We calculated that oxygen is a first order reactant. So times the concentration of oxygen gas to the power of 1. And if you want to calculate the value of K for a fixed temperature, all you need to do is plug the data from one of these experiments over here and you can find the value of K. More on that later on. That has been Mr. Diego Tutoring. So follow me on social media, on my Instagram, on my TikTok account at Mr. Diego Tutoring. Please also follow my YouTube channel at Crushing Chemistry. And if you want some private tutoring lessons from all over the world, please DM me on Instagram and we can schedule a tutoring session for you. This has been Mr. Diego Tutoring. See you next time. Bye-bye.